Okay, welcome to lesson 3 in our B6 topic, our final biology topic. And in this lesson we're going to be looking at how we can use microbes. Now this is probably one of my favourite lessons, as it talks about production of cheese, yogurts, two of my favourite food, plus a couple of my favourite drinks such as cider, wine, beer, and we look at how we're actually producing those using microbes. Okay, so here are our objectives for our lesson on useful microbes. So by the end of this lesson you should understand how microbes can be used to produce alcohol and other foods. Now bacteria can be really useful, and it's often used to make several products that you will find commonly on the market. The first is compost, and compost that you might actually be contributing to at home if you have a compost bin that's collected by the local council. The second is silage, and this is winter food for cows. It also gives you that nice country smell when you're driving around in the farm areas. The third, which is what we put on our chips but isn't salt, is vinegar, which is produced from alcohol. Now the last two are probably the ones that you are aware of that come from bacteria, and that is cheese and yogurt. And they're made from bacteria as well. Now making yogurt involves several stages. Now it's carried out in one of these, which is a steel fermenter, and this can hold up to around about several hundred litres of yogurt. Now the first stage producing yogurt is to sterilise the equipment, and this is done by steam cleaning. The steam is obviously at 100 degrees, which will kill any pathogenic bacteria. The second stage is pasteurisation, and that's heating the raw milk up to 80 degrees and then cooling it rapidly. Now what this will do is this will kill any of the bacteria that is in the milk itself. Now the third stage is to warm the milk to 40 degrees. Once the milk is warmed, the live bacteria, which is lactobacillus, is added. Now what that does is it breaks down the lactose which is in the milk, and that gives the yogurt its characteristic taste. Now what happens now is it's left in the warm milk, and the mixture is incubated for several hours. Now during this time the bacteria will reproduce, and the lactose will be converted into a lactic acid, and that's what makes the yogurt thick, and it also gives it that acidic, sharp taste. Now once the yogurt is made, the manufacturer will then sample the yogurt to check it has the right consistency and flavour before they can add flavours and colours before they put it on sale. Now fermentation uses yeast cells. Now yeast cells can respire in two ways: aerobically, which is with oxygen, or anaerobically, which is without oxygen. Now the fermentation reaction is this here, where you take sugar and you produce ethanol, which is an alcohol, and carbon dioxide. Now the simple equation is this one here. So you've got your sugar, normally form of glucose, that makes ethanol, which is C2H5OH, plus you get two lots of carbon dioxide. Now a lot of food processing factories have a lot of wastewater from washing their equipment that we've seen with the previous section on yogurt making. They use steam, which is water. Now yeast is often used to break down the sugar, as it's very efficient, so they add yeast to the wastewater before they put the sugar into into the waste supplies or into the rivers. Now, fermentation is a very, very key reaction in terms of its production of alcohol and alcoholic drinks. Now, we've got a variety of different drinks that all use this equation, but all have different flavours and different finished products. And here are three common ones that you've probably heard of, hopefully you've not tried. So obviously wine is made from grapes, beer is made from malted barley, and then you have apples that are used to produce cider. Now, with some of these ciders and wines especially, the carbon dioxide that's produced is often left in there to make the drinks fizzy. Otherwise, the carbon dioxide is allowed to escape. Brewing beer has been going on for hundreds and thousands of years. It's got a very specific way of making it. So what we're going to do is go through how we can actually go through the brewing process. Now, stage 1, barley seeds are mixed with water. Now what this does is this will break down the starch molecules into the sugar molecules. Stage 2 is known as mashing. Now this is where hot water is added to extract the sugar. Stage 3 is where the hops are added. Now the hops are added to give flavour. Stage 4, the yeast is added to ferment the sugars into alcohol. And this is done in a warm environment so that the yeast can reproduce and respire. Now you need to remember as well that this is done anaerobically, so with no oxygen. Now the yeast that's used has been grown specifically for this job, and it's been produced without any oxygen, as again it will then start to respire aerobically, and that will produce carbon dioxide and water and produce no of the alcohol, which is the whole point of producing this. Now once we've done stage 4, stage 5 is sealing the tank, and that's for two reasons. One is to again allow for that yeast fermentation reaction, and the second one is to prevent any unwanted microorganisms or pathogens from getting into the mixture. Stage 6 is clearing, where a chemical is added to clean or clarify the beer into a clear liquid. Now stage 7 is similar to what we had in the the yogurt producing section, and that's where the beer is pasteurised. Now the pasteurisation of beer is where the beer is actually heated to 72 degrees for 15 seconds. This kills the harmful microorganisms and doesn't affect the taste. It is done in the bottles so that we don't get any spoilage of the microbes. Now the final stage is where it's bottled or casked, and this is done once the microbes have been killed, because otherwise we could end up with that continual fermentation reaction, which will produce lots of carbon dioxide, increase the pressure, and can cause the bottles to explode. Now in terms of fermentation, the rate in which it occurs has a graph that looks like this. So with continued temperature, okay, I need to apologise. I think I've had a crash with the video recording system. Now, as the temperature increases, the rate of fermentation increases until we get to a specific point. Now, at this point here is about 40 degrees. Now, above 40 degrees, we know that we get the denaturing of enzymes, and that causes the fermentation process to stop. Now, distilling is where we can actually make high alcohol volume drinks such as whiskey, rum and vodka. Now these drinks come from a different source compared to the wine, beer and cider that we've already seen. Now rum is actually made from cane sugar, whereas whiskey is made from malted barley, and vodka, believe it or not, comes from potatoes. Now in order to do this and actually sell it, you need to have a license. Now the process of distillation is very, very simple. You take a normally fermented drink and it will go into here. Now what happens then is the solution, or the alcoholic drink, is evaporated. Now when it evaporates, it turns into a gas. Now once it's turned into a gas, you can then condense it back into the liquid. So in here, this is where you would collect your fermented or distilled alcohol. Now because alcohol has a lower boiling point than water, that's where you actually get the concentrated alcohol from. Now the reason why you can't ferment this in the first place is because if you have a high concentration of alcohol, the alcohol actually poisons the yeast, so it actually kills the yeast to prevent any more alcohol from being produced, which is why you have lower concentrations for beers and wines than you do for spirits, because you can only distill the spirits and you can't actually produce the high concentration of alcohol. Okay, so we have looked at the fermentation reaction. We've looked at how microbes are used to make blue cheese, and we've looked at the detailed method of making yoghurt and how we can make beer. Now I have seen 6-mark questions based on those, so you need to make sure we're clear on the steps that we produce those with. Also about the distilling and how the alcohol can actually poison the yeast and actually cause it to stop working, which is why you have to distill things like rum, whiskey and vodka and any spirit really, and you can't just produce it straight away. Anyway, I hope you enjoyed this and I'll see you next time. Bye bye.